Hey everyone, so in this video we're going to be provisioning a Kubernetes cluster on AWS using Terraform, and once we have the infrastructure ready, we're going to make use of Ansible to configure those EC2 instances so that we could have a fully functional Kubernetes cluster up and running. Okay, so everything will be automated. So whenever you go and join any company, this is how you're going to be implementing things. You're not going to be using console or the cloud provider's dashboard or anything of that. So no one manages infrastructure using mouse and using clicks. Okay, those are the thing of past now. So Terraform and Ansible. So Terraform is used for infrastructure as a code, and Ansible is used for management of or configuration of those servers. So I've mentioned everything that we're going to be performing in this session in this README file. You guys can read this and implement things as is. Okay, so let me show you the Terraform code. First thing first, the backend. So for this particular project, we're using S3 as a remote backend. The reason why we use S3 as remote backend is to have that persistence of state remotely, so that even if you have multiple team members working, you should be able to work. You should be able to have the most recent state of the infrastructure without having any issue. Like if you have this state locally, it's massive issue. You may have accidentally delete that. And not only that, working as a team becomes really difficult. So it's recommended to always, absolutely, in fact it's must to have a remote backend. One thing which I want to point out here before moving forward is previously we had to use DynamoDB for state locking, but now with the latest version of Terraform we don't have to do anymore. Terraform has pre-configured this, and they've already they've implemented the state locking built in. So we just have to configure S3. No need to worry about DynamoDB going forward. Okay, so this is the backend that we're using, and let's jump right into the actual code. So for this session we're using AWS, so that is why the provider is AWS. And because to spin up a Kubernetes cluster we need EC2 instances, right? And then to configure those Kubernetes related configurations, you need to have access to those EC2 instances. So to have the access to those EC2 instances, we are using SSH, and we're generating the SSH keys for those EC2 instances and saving them here locally. Okay, once we run this code, it will generate an SSH key. That key will have that key here, and the name of the key will be K8s-key.pem. okay, so this is what this block is doing. Then comes the networking part. We are creating a VPC, AWS VPC, and this is the server of the VPC. And in this VPC we're creating public subnet A and public subnet B. Why we are creating two subnets? To make things highly available. Okay, we put these subnets in different regions, and this makes things highly available. And when something goes wrong with one VPC, you still have your infrastructure and your EC2 instances running in another availability zone. So that is the reason why we have two availability zones and two multiple subnets in multiple availability zones. And then the internet gateway, so that we have access to the internet, and then the route table, and then route table association. This is simple things we already know about networking VPC. If you don't know, you need to first work on those concepts and then come here, because it's going to be confusing if you don't understand those things. Then the security group, we're opening the port 22 so that we could SSH. Then port 6443, this will be used by the kubeadm server. Then the node port services use the port in this range, and that is why we have allowed these port in this range as well. And then for internal communication, we have opened these ports. And the thing to notice here is that here this error block is 0.0.0/0. That means these ports are available from the internet. Same for this one as well. But here for internal communication, we have mentioned this error as this error of the VPC. That means these ports are only accessible from within the VPC. Okay. And then here we are spinning up the EC2 instance for master and spinning up EC2 instance for workers. And how many master nodes we need? We are giving it the value from the variables, the count number of master nodes, the AMI, that's also we're giving it from the variables, the instance type, the subnet ID, and same goes for this one. Okay, so this is how we are provisioning the infrastructure. So if I show you the variables, the region we're using, the AMI, the instance type, the master node, and then the worker node count. So we are provisioning one master node and two worker nodes. Okay, and the outputs.tf, it will, once this Terraform code is executed, we'll have the IP of the master nodes, IP of the worker nodes, and then an SSH file here, SSH key here, so that we could SSH into the EC2 instance. Okay, so let's execute this Terraform code. cd into Terraform infra, and first thing first, you have to do Terraform init and then Terraform flan. Because I've already done that, so I'm not going to do that again. I'm applying this directly to Terraform apply dash auto approve. You don't have to use auto approve more, especially in production, because this is not recommended in production, but I'm using this so that I don't have to type the yes manually. But in production, always avoid using this auto approve command. Okay, so this will provision the infrastructure for us. It will take some time, so I'm gonna pause this video, and once we have the infrastructure ready, I'll come back and resume the video, and then we'll continue things from there on. Okay, so we are done with the execution of the Terraform script, and now we have the master node IP, the SSH key here. Yes, you can see that this is the SSH key which it has created, and then the IPs of the worker nodes. Okay, so next is, now let's jump into the Ansible folder here. These are some of the playbooks. One is master.yaml, one is worker.yaml, and one is all.yaml. So before going into these codes, let me explain the inventory.file. In the inventory.ini, we have this is where we mention all the servers which we want to manage. In our case, we want to manage this master node and then these two worker nodes. Okay, so we have to copy the IP address of these and update it here. So in this file, you mention all the hosts or all the servers which you want to manage, and their IP address, their SSH details here, right? So here we have these are basically groups. We call them groups. We have one group here, another group here, and another group here. We group the servers so that it becomes easy for us to manage. So whenever we want to reference these group of hosts or servers, we just make use of this worker, right? This makes things easy for us to manage. So this is how we mentioned in the inventory.ini, like these are the servers that we want to manage. So let's save this and let's jump right into the all.yaml. So this all basically means here this will be executed on all the hosts. Here you can see that here is another group which has the master group as well as the worker groups. Any server which is in the master and any server which is in the worker will be managed by this all group. Okay, So that is what this all thing is referencing. So this particular playbook will be executed on all the servers that is in the all group. So there are some steps we need to do whenever we want to run a Kubernetes cluster or prepare a node for a Kubernetes cluster. First thing is you have to disable the swap. You have the command for that. Then you have the load the kernel modules. Then you have to download the Docker, set up the install the containerd, and then download and configure the Kubernetes app repository, and then install the kubelet, kubeadm, and kubectl. So this is what we have done in this playbook. So these are some of the things which you have to do on all the servers, like the master and all the workers. So that is why we have mentioned here this will be executed on all. So this particular all reference to this word here. Okay, so let's first go into this playbook folder and let's execute this command. So this is the command. So Ansible playbook -i means the inventory file, and then the name of the playbook that we want to execute. So we want to execute this on all the servers. Okay, so let's enter this command. So now this will SSH into all these servers which we have mentioned here, and then try to execute and perform all these tasks. So this is going to take some time, so I'm going to pause the video, and once it is done with this, I'll come back and then we'll execute things from there. Alright, so the first playbook has been executed, and now all the nodes have the required dependencies already installed. That means that now we can initialize our cluster. Okay, so to initialize the cluster, the command that we need to run is, let's close this one so you guys could see exactly. So this is the playbook that we need to execute. Okay, Ansible, and then Ansible playbook -i inventory.ini, and then masters.yaml. In this master.yaml, I'll show you what it has. Let's execute this first, and in the meanwhile I'll show you what is there. So all it does is, this is the master.yaml. All it does is initialize the Kubernetes control plane by using Kubeadm. We have already installed the Kubeadm using this all.yaml in the first step, and now it will initialize the Kubernetes cluster, and then we'll have our Kubernetes cluster up and running. It will also install the CNI plugin. You guys can go through this file, what it does. Basically, it has 4 tasks: initialize the Kubernetes control plane, create .kube directory for the admin user, copy the kubeconfig file for the admin user in the inner directory which this admin user has access, and then check the cluster nodes using the kubectl get nodes. And then once we have all the nodes ready, in this case we have only one node because we haven't joined the worker nodes yet, so it will show you have only one node, and that's the master node, and then it will deploy the Calico CNI. So we're done with this. As you can see, that not ready control plane. Okay, so we have our Kubernetes cluster up and running, and now it's time to join the master nodes. So to join the worker nodes, sorry for this, so all we need to do is to execute the worker.yaml playbook. So let me show you the worker.yaml file. What it does is check if the node is ready. It's already part of the cluster. If we have already executed this or playbook, then there could be a chance of this particular node already part of the control plane, right, or the cluster. So in that case, it will skip this whole playbook for that particular node. Otherwise, it will run the join command. All it does is join the cluster by using the join command that we get. Okay, so let's check. Okay, so now our workers are part of the cluster. So we have a fully functional Kubernetes cluster up and running. So now I have to check like our Kubernetes clusters up and running or not. So to check this, we already have the IP of the control or of the master node, and we already have the SSH key here. So we can SSH into this master node and then see the like we'll execute the kubectl commands there. Okay, so let's move into cd into there. Let's cd into the Terraform info because we have the key there, and let's do ssh dash I, and then we have to specify the key. What is the name? K8s key. This is the key, and then the user is Ubuntu at the rate of what is the IP of the master node. This is the IP, so let's copy it from here. Let's enter. So we are SSHing into the master node. Now we are into the master node, as you can see this, and let's execute kubectl get nodes. Okay, it's having some issues, not really sure why. Kubectl get nodes, kubectl get pods. Okay, we're having some issue. Okay, so I've tried to debug this issue, and turns out that there was actually no issue. It was just that the cluster was not yet ready, so that is why we were not getting any response. Okay, so this is how we spin up the Kubernetes cluster, just to show you that I'm actually logged into the master node, and if I execute like kubectl get nodes, I should see that I have, this is the master node, and these two are worker nodes. So this is how you spin up a Kubernetes cluster using Terraform and configure it using Ansible.